Hello, today we're going to talk about how to create value objects in Ruby the idiomatic way, or what I believe it is the idiomatic way. So let's start. What is a value or value-like object? So these are simple objects. This is the general definition that have at least the following properties. They can have multiple properties, but two I think are important for us today. They are comparable by type and value, and they are immutable. When talking about Ruby and Ruby OOP, a value object is a simple object that represents a concept in your domain and knows how to respond to some simple messages like what is the value of this property, what is your representation as a string, are you equal to this other object instance in value and type, and so on. Now, here is a simple example. If you think about a point that is in 2D, you always have to carry around X and Y properties. So instead of just writing a hash, and you can have an object that will allow you to ask it questions about it or sending messages and have a bit more complex behavior. So for example, you can define a method called quadrant, and then you can find out in which quadrant that point is defined. Now, why use a value object? Here are a couple of reasons. One, it keeps data together using an immutable object. So then you can be sure that as you pass this instance, the instance of this object along through your code, nothing has changed or nobody changed it. It is a group of values that should be together under a meaningful name. You saw there that instead of looking at X and Y, I now look at a point, so it has a meaningful name. It is greppable, meaning you can easily find all the places in your code base when this object is used. And if you are using some kind of LSP or some kind of processing, you can have go-to definition, and so it makes simple to refactor it. And if you think about why an object and not a hash, here are somehow similar reasons, but I rephrase them for a hash. First is naming. A hash is anonymous, and an object it has a name. So, and if you find a good name in your own domain, that's a huge win only from this one. Greppability, because now this structure has a name, it's easier to find it. And flexibility, you can add utility methods, computed properties, or predicates. Of course, you can still use a hash if you want to and if you don't need all the other stuff that I describe here. Now, there is an idiomatic way in Ruby since 2022, and this is Ruby 3.2, where the data object was introduced. And let me explain a bit about this. How you define a data object? You write it like this: price equal data.define and then a series of keys, which will be the attributes that are required when you instantiate this object. Now, mind you, all the attributes that you put here are required by default. So how to instantiate an object? The simplest and the default form is through keyword arguments, as you would instantiate an object, a simple object that has in the initializer keyword arguments. But there are other forms. You can use position arguments. You can use this alternative form construct which is with square brackets, or this alternative construct in a hash-like form with square brackets, which I never use, but I found it very interesting. Now, properties of this data object in Ruby. It is immutable. So that means there are no setters defined and you cannot define them. So here I try to call a setter and you see that I got no method error. Now let me try to force a setter. So I define a custom setter read and I try to assign a value to the instance variable, which is amount. And you'll see here that it gave me frozen error. So it knows that I tried to change an internal variable which is frozen. And it's comparable by type and value. So here I'm defining multiple prices with different values. You see price 1, it's 50 USD, price 2, 40 USD, price 3, 50 USD. You see that it has different object IDs, so these are different objects, but I can say that price 1 and 2 are equal, and price 1 and price 2 are not equal when I compare them. So defining custom methods. You might notice that if you browse the documentation that this data object has limited amount of methods. There are, I think, 10 methods specific to this object, not taking into consideration the methods that are coming to the inheritance chain. So for example, I can define a toString or redefine a toString if you want, and I can make it print first the currency and then the amount, and this will work. Because the define method accepts a block where you can define or redefine the current methods. Now, you, for example, might think, okay, but I just want to kind of copy an instance, but change one amount. So for example, here I did price A, which is an instance which I cannot change the values, and I want to create price B, which should be similar in general with price A, but only have the amount changed. So, and this is where the with method comes to. You can make it set up default values. So you can say, for example, that You can define it like the initializer, you should specify amount, but when currency is nil, it should have euro. So for this is how you can define it. I also put here the shortest form if you like the endless method. You can mix it with pattern matching. So for example, here I'm defining currency to have a specific structure with data defined, and then I say price. It's defined to have required amount and currency. And then in initializer, I say that amount should be an integer and currency should be a currency object. And then you see here that if I give it a string or something else, it gives me no matching pattern error. Now, you can also use the struct. The struct, it behaves pretty similar if you put the keyword in it with the data object, but just to remind yourself that the struct, it's mutable. So you have to freeze when you create an object to make that immutable. So you see here in the second example that, in the first example, sorry, that I can change the amount, and in the second example that I cannot change the amount. A bit on the immutability, just note that data objects are frozen but not deep frozen. Actually, this is true for any object that you freeze. So for example, here I'm putting inside a price, a currency, and you can see that if I make currency struct, so that is mutable, I can change the currency code. A trick, you can use the reactor make shareable to freeze this object, to make a deep freeze on it. So here, for example, if I call reactor make shareable when I instantiate a new price object, then this is deeply frozen and I cannot, even the structure, the currency structure inside it, I cannot change. I'm not sure this was the purpose or this is the purpose of reactor make shareable, but I found it a nice trick. Recommendation. My recommendation is to combine data object with only data object or only with immutable and immediate objects. And this way you make sure that not only the outer object, but also the internal objects are remain frozen. So nothing will change that structure for you. You can read the full article with mod code samples and documentation link on my blog, where I shared all of this with some extra links and extra information about it. That's it for today. Thank you. Bye bye.